Hello there, Algebra 1 students. This is Chapter 3, Section 3, Rate of Change and Slope. So in a nutshell, rate of change is basically equal to the change in y divided by the change in x. Alrighty, so we're going to start off with an example here. Example 1, use the table to find the rate of change, then explain what it means, explain its meaning. So basically we have here a bunch of x values and a bunch of y values. It doesn't really matter, sorry for the bell there, that's always annoying. But anyway, we can pick whichever 2 points we want. So I'm just going to go ahead and be really generic, and I'm going to pick these first 2 points right here. And what I'm looking for is the change in y. So I want to see how much the y value has changed. And to figure that out, all I have to do is a simple subtraction problem. When you go to the store and you buy something for $12 and you pay them with the 20, how do you calculate how much change you're going to get? You just take your 20 and subtract your 12 and you get $8 back. So the same idea here. We're looking for the change in the y values. So the current y value is 156. So I'm going to subtract the previous value, which is 78. That's the change in y. And the change in x is going to be the 4 minus the 2. It's important to always go in the same order. So if I go 156 minus 78, I have to go 4 minus 2. I don't want to go 156 minus 78 and then go 2 minus 4. You always want to be consistent. So in this case, 156 minus 78 is 78. And 4 minus 2 is 2. And 78 divided by 2 is 39. So my rate of change right now is 39 over 1, or just 39. And so to explain what it means, since 39 is on top and 39 is the y, 39 is the cost in dollars for every computer game. So x is the number of computer games. So what we have is on the top is the y variable, on the bottom is the x variable. So the y variable is dollars and the x variable is computer games. So this means $39 per computer game. And that's all you have to do. So you will now try this little guy, and then we'll move on to some more examples. So here I have a graph, and this graph is in your textbook. It's on page 173, but I pretty much did a pretty decent job of writing out what it said, so you don't have to go to your book, but anywho. It says find the rate of change for the years between 2000 and 2002. Okay, so you can see here that on my x-axis I have 2000 and 2002, and I want to find the difference in the y values. So the graph tells you that this is apparently 324, that's the y value for 2002. So we have the x value is 2002. And the y value is 324. And then we have in the year 2000, we have 317 as the y value. Alrighty, so to find the rate of change, what we want to do this time is the same thing we did before, is to find the change in the y variable. So we're going to take the 324 and subtract 317. And that's the change in the y values. Notice that this time I went from 324 minus 317. So now I have to go 2002 minus 2000 to get my rate of change. So 324 minus 317 is going to give us 7. And 2002 minus 2000 is 2. So my rate of change is 7 over 2. In part B, it says explain the meaning. So one thing I did here is the graph shows the number of people who visited the U.S. theme parks in recent years. So this is the years, and this is the amount of people that visited. So we basically have that, and it's in, if you look at the book, it tells you attendance in millions. So this is 320 million. So this would be 7 million attendees every 2 years, roughly. Okay, that's what that would mean there, 7 divided by 2. And then you want to do the exact same thing for this year, 2002 to 2004. So in that case, I'm going to come over here, I'm going to put on the bottom for sure is 2004 minus 2002. And then I'm going to find the y value for 2004, which is 325. And the y value for 2002, which is 324. So 325 minus 324 is 1, and 2004 minus 2002 is 2. So this time we get 1 million attendees for every 2 years. So basically, in the first 2-year period, you had 7 million attendees for those 2 years, and between 2000 and 2004, you only had 1 million attendees for 2 years. So it kind of dropped there a little bit. Okay, so it says explain the meaning. So we explained the meaning already. Part C: how are the different rates of change? Shown on the graph? And that I will tell you. I don't have space to write the answer out, but you can write it in your notes. Is by the steepness of the line segment. So we can see that this line segment is steeper than this line segment. Just think about having to climb this segment. If you were climbing this piece, it would be harder because it's at a higher incline, and this is an easier one, and then we're back to a higher one again. So basically, that's how the different rates of change are shown on the graph, by the steepness. So now we want you to do example number 2, and again, it's referring to the same graph. So you'll do that, and then we'll carry on. So now the other thing that we need to know for this example is that in order, because this question says determine whether each function is linear. We have ways of doing that when we see an equation, but we don't have an equation right now. We're looking at a t-table. So from a t-table, it's also possible to know whether or not the function is linear as well. And the way we know that is because the slope of a linear function is always constant. I will say that again. The slope or rate of change, which is the same thing, the rate of change for a linear function is always constant. It means it's always the same. Okay, so what we're going to do is we're going to show you how we can find if these functions are linear. So it's kind of tedious, but basically what I have to do is find the slope between all of these points. And every single time I find the slope, it has to be the same for each pair of points. Otherwise, this is not a linear function. Okay, so what we're going to do is we're going to say -8 minus -6 over 4 minus 1. So that's going to be -8 plus 6 over 3. And -8 plus 6 is -2/3. So the slope, or the rate of change for these 2 points is -2/3. I'm going to calculate that again for the next set of points. And if it's not -2/3, this is not going to be linear. So I'm going to go -10 minus -8 over 7 minus 4. So I get -10 plus 8 over 3, which again, -10 plus 8 is -2/3. So far, so good. Okay, then I'm going to try the next one. And I'm kind of running out of space here, but I'm going to do -12 minus -10 over 10 minus 7, which is -12 plus 10 over 10 minus 7, which is 3. So -12 plus 10 is again -2/3. And the last one is going to be here, so we're going to go -14 minus -12 over 13 minus 10, which is -14 plus 12 over 13 minus 10, which is 3, and once again we get -2/3. Now because all of these had the same rate of change, then we know that this is in fact linear. Yes, it is linear. So now we're going to do the same thing with these guys. We're going to get, again, the change in y, so it's 12 minus 10 over -1 minus -3. Be careful with those minus negatives because those do become positives. 12 minus 10 is 2, and then -1 plus 3. So we get 2 divided by 2, which is 1. So my slope there is 1. I try the next pair of points, and I get 16 minus 12 divided by 1 minus negative 1. Again, be very careful with those negatives because you might be thinking, oh, 1 minus 1 is 0, but it's not 1 minus 1, it's 1 minus negative 1. So 16 minus 12 is going to be 4, and 1 minus negative 2, and 4 divided by 2 is 2. So already we can see that these two pairs of points have different rates of change, so this is not linear. We don't even have to keep going because once you find one that doesn't work, then it's not linear. So we've just saved ourselves a couple of extra steps there. Alrighty, so now we're going to ask you to do this little guy, and then we're going to move on. So here we go, slope. Like I said earlier, it kind of slipped out a little while ago. Rate of change, when you're talking in the sense of a coordinate plane, like an XY axis, we have a name for it, and it's called slope. Okay, but it's basically the exact same thing as rate of change. And so the letter that we use to denote slope is M. Don't ask me why, that's a weird one, because it starts with an S, slope, but we don't use S for slope. I'm guessing that the S is already taken up by, I don't know, speed. So we use M for slope. And so verbally we can describe slope as rise over run. Again, if you were walking along this line, how much is the rise versus the run? So it's a ratio. Another way of thinking of it is change in y coordinates over the change in x coordinates, which sounds a lot like what we just did in the previous examples. And then of course, if you have two coordinates, this is your formula right here. This is probably the part that's really, really important for you to make sure you have. So I have a diagram here for you of a line. And what I've done is I've kind of made everything color coordinated. I made my x's red. So basically this is my x1 value. This is my x2 value. Don't get scared by the one and the two. It's just denoting that there's a first value and a second value. So this is called x sub 1, x sub 2. And we have y sub 1, y sub 2, and of course x sub 1 and y sub 1 kind of go together, and x sub 2, y sub 2 go together. But most of the time we just call it x1, y1, x2, y2. You don't have to say sub, but technically it's a subscript, so we kind of say sub 0, sub 1, sub 2. But we can just call it x1, y1, x2, y2. If that's the case, then here's my x1 value, my y1 value, here's my x2 value, my y2 value. And if I want to find the rise, we're talking about how far it goes up. There's my rise. And then your run is how far it goes left to right. So the rise is up or down, and the run is left to right. Okay, so that's my rise over my run. So my rise ends up being basically the same thing as the change in y coordinates, because I'm going to go from here on the y-axis up till here on the y-axis. So my change in y is done, like I said before, very easily by just subtracting the two values, which is why we have in the formula y2 minus y1. We tend to take the bigger value and subtract the smaller one. So y2 is above y1, so it's bigger. So y2 minus y1. And then the same thing for the x-axis. x2 is larger than x1, so we take x2 minus x1, that's the change in x. So just another way of looking at that. So the first thing we're going to do, I'm just going to show you how this works. How do I calculate the slope? And so here I have a pair of points, and I don't need a graph. I can just do it from the pair of points. And the first thing you want to do is label, label, label. So I'm going to call this x1, and this is going to be my x2. It doesn't really matter which one you call x1 or which one you call x2, but you do have to stay consistent. You don't want to call this x1, y2. It has to be x1, y1, x2, y2, or this could be x2, y2, x1, y1. But you can't mix and match. So then I'm going to go with my y's. This is going to be my y1, my y2. Okay? So to calculate my slope, I'm just going to follow the formula, which is y2, so negative 2, minus y1, which is 3. On the bottom, I'm going to take my x2, which is 2, and subtract negative 1. So I get negative 2 minus 3 is negative 5. And again, be very careful. This is 2 minus negative is a plus 1, so I get 3. So my slope is negative 5/3. Alrighty? And that is how you calculate a slope. So we're going to do some other examples here. You can get a slope that is positive, negative. You can even have a zero slope. Give me a second.
Can I? Yes, so today, is today
I don't want to talk on this. Yes. Yes, it is quiet.
Yep.
Sorry about that interruption. So, as I was saying, we're going to calculate the slope. So remember what we said a little while ago? It's very important that you label your points. x1, x2, x1, x2. I'm just going to get ahead of the game here. x1, x2. And then we want to label our y's. y1, y2, y1, y2, y1, y2. Okay, so my slope is going to equal, the formula was y2 minus y1, so in this case it's going to be 5 minus 0 divided by x2, which is 1 minus negative 2. And again, be very careful with those minus negatives. So 5 minus 0 is 5. And be really careful here. We got to get 1 minus negative is plus. So 5/3. And I feel like we just did that. But we get positive 5/3 for that slope. And then over here, we're going to do it again. And we've got y2 is negative 3 minus y1, which is 4. And on the bottom, we have x2, which is 2, minus negative 3. So negative 3 minus 4 is negative 7. And remember that this is now 2 plus 3, because it's minus negative, and 2 plus 3 is 5, and we get a negative slope, negative 7/5. Our first one was positive 5/3. And then we have one last option. And in this case, our y2 is negative 1 minus negative 1 divided by 2 minus negative 3. So here we have negative 1 minus negative 1. So again, be really careful that that's negative 1 plus 1. Negative is positive. On the bottom as well, it's 2 plus 3. And negative 1 plus 1 is, you guessed it, 0. And 2 plus 3 is 5. So 0 divided by anything is 0. So yes, it is possible to have a 0 slope. We can have a positive slope, we can have a negative slope, or we can have a 0 slope. And so now we're going to have you try these 6 examples here, but they shouldn't take you very long. It's not a very hard process there. And then we're going to move on to one other scenario that can happen, and it oftentimes gets confused with the 0 slope. And that's this guy. It says find the slope of the line that passes through negative 2, 4, negative 3. So again, you know what I'm going to do? I'm going to come over here, I'm going to say label, 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 x1, x2, y1, y2. Calculate the slope. M equals y2 is negative 3 minus y1, which is 4, divided by x2, which is negative 2 minus negative 2. And negative 3 minus 4 is negative 7. And divide that by negative 2, and then minus a negative is a plus 2. So this is actually going to be negative 2 plus 2. And then you guessed it, we're going to get negative 7 divided by negative 2 plus 2, which is 0. And I'm almost scared to ask, but we said earlier that 0 divided by anything is 0. That's true. But this is not 0 divided by something. This is something divided by, this is backwards. This is actually undefined. It is not the same thing as 0. Negative 7 divided by 0 is not 0. Negative 7 divided by 0 is undefined. So it's very important that you not put 0. It's undefined. So now we have 4 options. We can have a positive slope, a negative slope, a 0 slope, and an undefined slope. So after you do this do-it-yourself question, we're going to go to our last example. And before we get to that, we're going to have this little summary of what we just talked about. It is possible to have a positive slope. And this is what your line would look like if it has a positive slope. It would always be increasing. You read a graph like you read a book from left to right. So the slope goes up as you travel from, like if you're walking a line, you're walking up from left to right. And then we have a negative slope, which is always decreasing, and it slopes down from left to right. Then you have what we call a 0 slope, and that's where the function is constant. The y values aren't changing, they're always the same, it's constant. And that's a horizontal line. And then you have an undefined slope, which is not even a function at all. So this is like your vertical line. And so those are your 4 options. So just as a little summary for you. But right now we're going to go to our last example, which is basically using our slope formula kind of backwards. So before we get started, I want to just rewrite the slope formula for you. Just in case you had forgotten it. And it says here, find the value of r so that the line through those 2 points, 1, 4, negative 5r, has a slope of 1, 3. So in this case, we're not being asked to find the slope. We already know what the slope is. The slope is 1/3. So I can already replace the m with 1/3 because I know what the slope is supposed to be. And then I'm going to come over here and I'm going to label x1, x2, y1, y2, and I'm just going to plug those numbers in. For y2, I've got r minus y1, which is 4. On the bottom, I've got, let's put this in the right. On the bottom, I've got my x's, so I'm going to go negative 5 minus x1, which is 1. So everything looks pretty normal right now. So what I want to do is just kind of simplify this. So I have 1/3. On the top I have r minus 4. On the bottom, negative 5 minus 1 is negative 6. And now I can actually solve this like a proportion, okay, which we did in the last chapter. So 1 times negative 6 is negative 6, and then 3 times r minus 4, which basically becomes negative 6 equals 3r minus 12. If you go 3 times r, 3 times negative 4 is negative 12. To solve for r, I'm going to add 12 to both sides. Sorry, I don't know why I put divide. But I'm going to add 12 to both sides. So I get 3r equals 12 minus 6 is 6. Divide by 3. And it turns out that r equals 2. So that means that if I put a 2 right here, then the slope of those 2 points will be 1/3. So now I need you to try these 2 examples in much the same way. One of the variables in the points is going to be an r. They're telling you what they want the slope to be, so you want to work backwards and solve for that. So once you've done that, then you will have completed your notes for this lesson, and I will see you in class. And thank you for watching.